And welcome to the expert breakout sessions for the Enterprise Integration Summit. This time we move to our expert from Red Hat. And with us we have David Codelli, Senior Principal Product Marketing Manager. David, welcome.
Thanks, Vance. Great to be here.
We're really glad to have David with us this morning. He's a 25-year veteran of business integration, including event-driven architectures, APIs, and many other techniques. He has worked on complex systems and applications across many enterprises, especially as we get into the disruptive world of modernizing and getting into distributed systems. And all that's going to be on display this morning as we hear from David about his session, Event-Driven Architecture, Getting Started with EDA Using Apache Kafka. What David is going to show us about is that with EDA, we're getting a much better use of data for performance and for accessibility for applications, especially those that are data-centric, more than just with APIs. So we're going to take a look at that in his session this morning and take a look at, frankly, how the new generation of integration is becoming much more friendly for cloud and hybrid architectures. You can download David's slides by just clicking that big red button under the view screen. You'll also see that David and his team have brought us some great downloads and resources. They're all available for you right now. No registration required. You did that to join us this morning. And if you want to connect with David, just submit your comment or question in that submit a question box. So with that, David, let me turn to you and tell us about event-driven architecture, getting started with EDA using Apache Kafka.
Thanks, Vance. And once again, it's a great pleasure to be here. I will be talking about event-driven architecture, and of course, one of the most exciting things happening in EDA, which is Apache Kafka. But I'd like to start by stepping back and just doing a retrospective on how application architecture has changed in the last 10, 15 years to put event-driven architecture in context. And I'm going to start with what we at Red Hat like to call the ye olde architecture slide. Basically, for 50 years, we've been writing applications in some variant of a monolith architecture. Whether it was client-server, mainframe, three-tier, pipeline processing, or something else, we had services that did different jobs, but were similar to each other in terms of, in particular, environments and languages. And they often, almost always, in fact, shared a common business tier and a common data format. In the last 10 years, we've moved to a new model with cloud-native microservices. In this new world, services are developed by smaller, focused teams with minimal dependencies between teams, the proverbial two-pizza teams. This approach emphasizes things like frameworks and sprints, hybrid cloud deployments, continuous integration, and many other innovations that weren't relevant or even available to monolithic developers. Microservices teams decided that the biggest problem was that the changing and testing bottleneck of monolithic architectures outweighed the reuse advantage of their shared object models. Instead, they organized around smaller teams that address point functions, each having their own data store. With each having their small data store to manage, these microservices teams are freed from storing their own data elsewhere and thus freed from the lockstep testing program involved in a share model. Even better, with no shared access layer, they are free to use the development platform and development language that suits them best. So they became distributed systems, often on separate virtual or physical machines, each with their own process and thread spaces. But while they didn't share a data tier anymore, they still have to share something. Updates to customers, for example, trigger or come with updates to other systems, operations, billing, etc. So the decoupling of systems doesn't mean you don't still need integration. The question is, what is now the state of the art for interoperability? New development practices require new mental models. In our mental models at Red Hat, we address microservices architecture interoperability from 4 aspects. First, APIs. It's clear that well-defined API contracts are the best approach for synchronous application-level interaction between services and with the outside world. I'm going to skip over the second one for a moment and go to the third one, which is data, another aspect. As each microservice owns its own data model, there has to be a strategy for virtualizing that data in a manner that allows query and updates from other services and from the outside world. The fourth mental model is enterprise integration patterns. Business logic often requires multi-step processes with routing and transformation across services, and that's where these EIPs come in. But in this presentation, I'm going to focus on the second aspect, which is events. What is an event? Pretty straightforward. An event is an action or an occurrence recognized by software, often originating asynchronously from the external environment that may or may not be handled by software. It's a change in the state of the world. At a high level, event-driven architecture is a way of designing applications and services to respond to real-time information, to respond to those changes in the state of the world based on sending and receiving information about these individual event notifications. EDA is, of course, often documented in sequence state diagrams like this one, showing how each actor responds to real-time events from other actors. Now, if you're more than 30 years old, you might be thinking, wait, I've heard of this before, or I've even used it before. And that's true. EDA is not new. You could go back to 2002 when Java 1.4 introduced event handlers as first-class objects. Or even further, you could go back to 1997 and say, well, really, when the first reactive programming language came out, it was called Fran, a derivative of Haskell. When that was released, that was when we first started doing event-driven development. And then if you're more than 40, you would say, no, you'd have to go back further, go back to 1993 and say, hey, Oracle and Sybase and DB2 introduced triggers around 1993, and that's event-driven. That allows you to capture any change to a row of a database and call any business logic you want by writing SQL code. And then some people are going to say, no, you got to go even back further. Go back to 1984 when the Apple Macintosh revolutionized the way humans interact with computers with a main event handling loop, where developers basically were tasked with interpreting every potential interaction that someone would have, a key press, a mouse down, a mouse up, a slide of a window. That really was event-driven. You had to decide what your application was going to do based on an arbitrary number of events that could be initiated from a user. And then if you're really an old timer, you're going to say, no, that's all new stuff. The first instance, or at least the first instance that I could find of event-driven computing was when the UNIVAC 1103 debuted, and it was the first computer that had operating system level interrupts, where your program could be stopped by the operating system because something else happened. And then you might have to regain control somehow and figure out where you were. Now, interrupts and event loops and triggers and programming language event handlers are all great things and still very useful, even within microservices development efforts. However, they are much less useful between microservices in a polyglot cloud application, if they work at all. Remember, microservices teams have their own data store, so they effectively hide the database from other teams, and thus triggers don't help. Similarly, interrupts are operating system constructs. Event loops and handlers are similarly restricted. They're restricted to the execution context. So microservices teams need EDA as well, and they can't get that kind of event-driven features from these older constructs. They need streams of data they can react to. In addition, cloud-native development has introduced new requirements that didn't exist in the monolithic area. They need to be able to move forward and backward in time in those streams. And they need to be able to interrogate those streams in the same way that they manipulate relational data. Monolithic EDA solutions will not achieve the requirements of cloud native developers, or at least they won't be sufficient by themselves. So what is required? What are the elements of an event-driven architecture? As we've said, microservices teams still need to access data that is owned by other teams. In fact, a common solution to this information sharing challenge is for each microservice team to replicate the data in an intermediate store of their choice and populate it with the data owned by other teams. This store might be a database, maybe SQL or NoSQL, could be a data lake, could be an in-memory store, could be a stream processor such as Apache Spark or Storm. The teams populate these intermediate stores with data streamed from other microservices. And Apache Kafka has become the streaming technology of choice for this and many other types of information propagation. Kafka is prized by these teams for performance, scalability, and the ability to replay streams so that teams can reset their intermediate stores at any point in time. What is Apache Kafka? Kafka is a distributed system designed for streams. It's designed to be horizontally scalable, fault tolerant, it's a commit log, and it allows distributed data streams and stream processing applications. Now, of course, being at Red Hat, I wouldn't be talking to you if Red Hat didn't have a particular interest and a particular offering related to Kafka. Our implementation of Apache Kafka is called AMQStreams. And of course, like all Red Hat technology, it's 100% open source, drawing from the Kafka community. What makes AMQStreams really interesting, though, is the delivery of Kafka on another extremely exciting technology for microservices, Kubernetes. Now you have the world's leading streaming technology on the world's leading container management platform. It turns out that putting Kafka on Kubernetes is not trivial because of a lot of technical reasons. Our solution to marrying these two is called Strimzi. And Strimzi is an open source project recently approved and accepted by the Cloud Native Computing Foundation, which is the same organization that hosts Kubernetes and a lot of other key microservices related technologies. Strimzi itself essentially provides operators for deploying Kafka and Kubernetes. And if you're not familiar with operators, they are essentially the state of the art right now for deployment and management of any kind of application on Kubernetes. So when you get AMQStreams, you get the core Kafka capabilities in container images, plus things like clients and administrative components, and finally, the operators from Strimzi. Now, AMQStreams is part of our broader total integration suite called Red Hat Integration. The integration portfolio enhances streaming with things like the Kafka schema registry for discoverability, connectors that allow you to do sophisticated routing and transformation with Camel on Kafka streams, as well as change data capture, which I'm going to talk more about in a second. But first, let me just add Apache Camel participates in this process by bringing together the rich, user-friendly transformation and routing capabilities of Camel directly into your data streams. So if you're only using Apache Kafka, you have to do a lot of work in code to decode the content of the data that's flowing in your streams. Camel can make you a lot more productive in that process, again, by offering you things like a GUI development canvas that represents your complicated data structures graphically. But one of the new things here is the change data capture. Change data capture is particularly interesting because it allows you to install agents that will detect changes in database systems and automatically propagate those to Kafka streams. You can think of it as a database trigger that publishes to Kafka as soon as it fires, giving you an immediate stream of data that consuming applications can subscribe to. Change data capture is based on, like everything from Red Hat, an open source community. And this particular open source community is called Debezium. Change data capture is available for a number of different databases. It's a very vibrant community. A lot of household names and leading edge companies are putting the technology into production deployment, and it supports a lot of different databases. Again, the benefit here being on-ramping your databases immediately as data streams so that you can do things like streaming analytics and build intermediate stores for your microservices development teams non-invasively. Now, I've talked a lot in this presentation about propagation of information between services. There is another side to event-driven architecture, which is, of course, application building for streaming data. Here, the industry has evolved as well with new reactive and serverless technologies. One particular technology that we've been involved with that is extremely popular is Quarkus, which is a Kubernetes native Java stack that is crafted from best-of-breed Java libraries and standards and tailored for containers and cloud deployments. The reason it's exciting is that it features amazingly fast boot times, incredibly low memory, not just heap size, offering near instant scale up and high density memory utilization in container orchestration platforms like Kubernetes. That's why we call it supersonic, meaning blazingly fast at startup and shutdown, and at the same time, subatomic, meaning super low memory. Supersonic, subatomic, with the rich functionality of Java. So, Red Hat integration is our solution for interoperability between microservices developers as well as with the non-microservices world. And we're seeing this applied in numerous implementation patterns, everything from classic event streaming, where you have systems that detect and react to critical conditions while querying a continuous data stream, broadcast and pipelines, so things like massive processing of log files across distributed systems, event sourcing, being able to treat these event streams as, well, what they are, distributed commit logs, so that you can recreate external data sources for internal consumption and be able to capitalize on the data while still keeping the systems decoupled. And then finally, the change data capture that I talked about, being able to provide a data stream non-invasively so that any updates to any data source are immediately available to subscribers. So that's it. We have lots more great information for you to learn about the exciting innovations in the community and at Red Hat. And here are just some of the resources. And I know, Vance, that we have more available in the conference. Just some I want to highlight right now. We've written a white paper on event-driven processing with MQStreams based on our experience with our customers. We also have a white paper on agile integration. It's actually an ebook. And I'm happy to say that anyone who writes an ebook is ipso facto an expert. Did I mention I'm a co-author on this ebook? But the ebook for agile integration is really our perspective on how microservices development fits in the broader context in organizations that have greenfield and brownfield applications and need to interact with their partners and legacy systems. So it's a great primer on interoperability in the real world. And then, of course, two of the community resources that I invite you to have a look at, one of which is the Quarkus community, where you can learn about supersonic and subatomic Java. And finally, Streamsy community, where you can learn about what it takes to get the massive scalability of Kafka to work in the cloud world as a cloud native application, which means that you need operators to deploy it to Kubernetes. And with that, Vance, I would like to turn it back over to you for any questions.
Excellent, excellent, David. Really great overview and a terrific look at some of the individual activities going on with Apache Kafka and this whole support for streams. It is such a hot topic right now. So thanks very much.
My pleasure.
You know, David, so many overlapping kind of Venn diagram pictures in my mind as you talk about APIs and event-driven architecture, and I guess to some extent even messaging and ESBs. Can you just contrast in general the integration strategies that many of our attendees probably have right now with what you're seeing with this new modern look at EDA?
So a lot of our customers are asking that question. They're saying, hey, I've got this ESB, and I'm moving toward APIs, or I also have a vibrant culture of APIs. How does this event-driven architecture affect me? And related to the answer on an integration strategy, they are complementary. Certainly APIs are the state-of-the-art unit for real-time interactions between microservices, each other, and the outside world. I would say that ESBs, we're starting to see less interest in ESBs because they tend to be centralized. So for synchronous interactions, a more modern architecture is a community of APIs under the governance layer of an API management product. That handles sort of one end of the spectrum. The other end of the spectrum is an EDA based on Kafka or something similar.
Let's kind of go a layer deeper. You mentioned, David, a couple times the ideas of synchronous or asynchronous, and certainly many of our integration guys are familiar with that in a traditional context, but help us understand what you mean when you're talking about either EDA or streaming.
Sure. Synchronous and asynchronous are really catch-all terms for a lot of different patterns. So with asynchronous, you might be talking about a messaging system, you might be talking about fire and forget interactions where there is a conversation going on, but it's at a higher level than the communications layer. And I used the word spectrum earlier, and I think that's an appropriate metaphor for basically two high-level ways of communicating between services. The synchronous has a lot of benefits, but some constraints. You get real-time interactions, but then you have to deal with availability of the network and what to do if the network's not available. And by contrast, you go to the other end of the spectrum, asynchronous interactions typically are less exposed to the risks of the network, and they solve a lot of problems. They solve things like how do you build a cache of data locally without coupling to someone else's service. So they solve a lot of problems, but you also do sacrifice that real-time, immediate acknowledgement or a return of the data that you need.
Which is a lot of reasons, the whole driver behind why people are investing in either streaming or Kafka to begin with, right?
Absolutely.
Let's have one more conversation about, like you said, the old timers versus the new generation of developers and integration professionals. You mentioned the idea, David, that monolithic EDAs don't necessarily meet the needs of cloud developers. A couple of comments on that. Could you explain a little bit more about either how Red Hat has made EDA less monolithic or what it is that cloud developers are helping kind of redefine what an EDA should deliver?
Sure. So one of the great things about microservices is that with smaller teams and with locally owned data sources, you can pick your platform. You can do Node development, you can do Java development, you can do C#, you can pick your language. And really, that's the reason you're seeing a proliferation of new microkernels and new languages versus 20 years ago when so much development was done either in Java or in .NET, because development shops had so much sharing in the monolith that they had to use the same programming language so that they could use the same client libraries. Well, so we've broken that monolith a while ago. We've said, you know what? Now that we have REST and APIs, doesn't matter what's on the other side of the pipe. Doesn't matter if they're programming Python or C or what have you. So these development teams, now they own their own data model and they communicate using REST or Kafka. And the question is, how can they capitalize on the development streams between the different development teams? And that's where, again, things like Kafka and change data capture can play a critical role.
Yeah, excellent, excellent. So let's talk about AMQStreams. Why don't you walk us through, David, some of the particular improvements or benefits that you're seeing with both the developer as well as the folks that have to worry about app performance?
Sure, sure. So again, the thing we're most excited about with AMQStreams is that it's Kafka on Kubernetes. It marries the two most exciting things that are going on in the microservices world today. And by the way, that marriage is not trivial. So there are a lot of organizations that have tried to get Kafka to work on cloud platforms and found that, again, it's not trivial. So with AMQStreams, you get the operators that allow you to easily deploy, manage, and migrate Kafka onto your container management system, as well as getting other things that make Kafka more beneficial to your organization. Things like change data capture, things like transformation and routing on Kafka streams. We're big believers in open source. We think that's why Kafka and Kubernetes and Linux and other things have done so well. Every change we make to open source technology, we make in the community, in the upstream. So we've taken what we think is the best of Kafka, and we've added things like Strimzi, like Debezium, also from open source communities, and versioned them and documented them in the way that we think is best for our developers and our customers.
Wow, wow, David, this has been a really fantastic conversation. I see the time is just about up, but before you go, on that theme of open source and availability, accessibility, walk us through how folks can learn more, either get a high-level architecture appreciation or maybe even play with it. I know Red Hat's got a great reputation for putting that code in the hands of developers.
Yes, and we love that IDN is making that available to listeners as well. So many great assets. And frankly, not just from our company, from all the companies that participate, which we're glad to see. So yes, the communities that I've talked about, Strimzi.io, Debezium.io, the Kafka community, are all great sources to learn and interact. And of course, at redhat.com, you have some great ebooks available for learning more about streaming, learning more about the broader integration strategy and agile integration, and of course, access to the technology, downloads, trials, registering, all that you can do at redhat.com.
Fantastic, fantastic. David Codelli, Senior Principal Product Marketing Manager at Red Hat. Thanks for a great look at the 2020 version of EDA and how it's really empowering a lot of these streaming architectures, notably with Apache Kafka and the cloud. And thanks very much for a great session.
So glad I was able to participate, Vance.
Oh, it's always our pleasure. And as David mentioned, many resources. We have a nice selection of them right here in David's breakout room. Just click on any of the ones that appeal to your fancy. You'll be able to get them right away. And for those of you looking to go even deeper, and there's so much going on here in this space, here's a slide that'll take you directly to some other resources David mentioned, directly from the Red Hat website and some of their partners. So thanks again, everyone.